Okay, in this video I'm going to solve the infinite potential well for a box centered at the origin going from negative a over 2 to positive a over 2. This video is to go directly hand in hand with the video where I did a box centered at a over 2 going from x equals 0 to x equals a. Alright, I'm not going to do the solutions really here because this is for symmetry arguments only. So if you want to learn how to actually solve all these things, look at my video on the well centered at the origin going from negative a to positive a. I did that in great depth. So the time-independent Schrodinger equation will give us the following wave function when solved. A times the cosine of alpha x plus b times the sine of alpha x. Therefore, we need to apply our boundary conditions. Alright? And the boundary conditions when applied will be as follows. You're going to get a times the cosine of alpha a over 2 plus b times the sine of alpha a over 2 is equal to 0. That's when you apply x equals a over 2. And similarly you're going to get a times the cosine of alpha a over 2 minus b times the sine of alpha a over 2 is equal to 0. So next thing we need to do is to start solving those, and I'll leave that for you. And what you'll find as a result is that alpha is equal to n pi over a. Alright? And we're going to get solutions which are both cosine solutions and sine solutions. So that's what I have so far. And the energy level values are going to be equal to n squared, pi squared, h bar squared over 2ma squared. Now the points to note here are, in the well which was centered at a over 2 and went from 0 to a, okay, its width of course was 2a, and we got the same energy values. We got these energy values here. So where the width of the well is the same, the energy values are the same. However, the wave function is not the same. In this case we get both cosine and sine solutions, and where we had the other well we only got sine solutions. And the reason for that is, in this case we're centered around the origin and we can apply symmetry arguments. So like this is a symmetric well. So as a result it is a symmetric well which gives us symmetric wave functions which are cosines and sine. Well, it is a superposition of cosines and sines. You're definitely going to get cosine solutions because cosine solutions are even. And in contrast, when we centered the well at negative a over 2, there was no symmetry argument, so we had an anti-symmetric well, and therefore we had an anti-symmetric wave functions, and sines are anti-symmetric or odd, and that's why we got sine solutions. The important to note here is the energy values don't change, however the wave function changes. So although the wave function changes, the information held within it does not. So thanks for watching. Please pass it on to your friends and subscribe to my channel.